Section 13-4, volumes of cones. The volume of a cone is the number of unit cubes or cubic units needed to fill the cone. The formula for the volume of a cone is 1/3 the product of the base area and the height of the cone. So volume is equal to 1/3 times capital B, which is the base of the cone, which is a circle, times the height. So volume is equal to 1/3 times the area of the base. Area of the base is pi r squared h. So it says since the base of the cone is always a circle, you can substitute pi r squared for B. So I've listed these out for us. Volume of a cone. Volume is equal to 1/3 BH. B is the area of the base. My base is a circle of a cone, and the area of the circle is pi r squared. So the volume of a cone is 1/3 times pi r squared times h. Now remember, you have the area of a circle on your formula sheet, and you also have been given the volume formula of a cone is on your formula sheet. V is equal to 1/3 pi r squared h. So you will have this formula on your formula sheet, okay? So the cylinder and the cone have the same height. They also have the same radius. So the area of their bases is the same. If you mark a cylinder in thirds, you can pour the contents of a cone into 1/3 of the cylinder. So let's look at example number 1. Looking at example number 1, it says what is the volume of each cone in terms of pi? What is the volume of each cone in terms of pi? So that means we're going to leave pi as part of our answer. We will not substitute in 3.14 in for pi. We will use pi in the problem, and we will leave pi in our answer, okay? So let's use our formula here. Volume is equal to 1/3 pi r squared h. So let's look at A part. What is the volume? Volume is equal to 1/3 times pi times r. The radius from the center of the circle to a point on the circle is 3 squared, so that's pi times 3 squared, times my height is from the highest point to the lowest point perpendicular, which is also 3, okay? So volume is equal to 1/3 times pi times 3 squared, 3 times 3 is 9, times 3. Now, think of all of those 9s, or the 9s over 1 and the 3s over 1. So we can simply multiply straight across. 1 times 9 is 9, 9 times 3 is 27. 3 times 1 is 3, and 3 times 1 is 3. We still have our pi. So what I did is I multiplied my numbers on top, just like I'm multiplying normal fractions. 1 times 9 times 3 gave you 27, and 3 times 1 gave you 3. Now 27 divided by 3 gives you 9. So the volume of this one is 9 pi. So the volume of A part is 9 pi. Okay? So let's look at B part using that same formula. Volume is equal to 1/3 pi r squared h. Looking at B part, volume is equal to 1/3 times pi times, my radius in B is 2, so that's 2 squared, times the height. My height in B part, highest point to the lowest point, is 7. Okay, so looking at B part now, so I have volume is equal to 1/3 times pi times 2 squared is 4 times 7. Okay, now again, think of those over 1, and let's just multiply straight across. 1 times 4 is 4, times 7 is 28. 3 times 1 is 3, 3 times 1 is 3 pi. So I have 28/3 pi. Now you can punch in your calculator 28 divided by 3. When you do, you get 9.33333. So I'm just going to round that to 9.33 pi. So volume is equal to approximately, or about, let's say about 9.33 pi and that's centimeters cubed. Let me put centimeters cubed on both of these answers because volume is cubed, area is squared, but any volume you're trying to find is cubed. And now let's look at C part. C part, using that same formula, volume is equal to 1/3 pi r squared h. All of it's multiplied together. Looking at C part, my radius is 1.5 squared, and my height, highest to the lowest, is 10. Okay? So for C part, I have 1/3 times pi times 1.5. Take your calculator. 1.5 times 1.5 is 2.25 times 10. Now these are over 1. So if you multiply straight across, 1 times 2.5 is 2.5 times 10 is 22.5. 3 times 1 is 3. And 3 times 1 is 3. And I still have my pi. Don't forget your pi. That's still here. I'm just multiplying straight across. Well, 22.5 divided by 3 on your calculator gives you 7.5 pi. Now that's approximately 7.5 pi, and that is centimeters cubed. Centimeters cubed.